So yesterday we took some notes and we talked about this. What is this called? That is the ideal gas law. All right. So what we kind of started seeing in the video was that everything in this chapter is going to be based around this ideal gas law. Okay? What?
Did y'all have a piece of paper or did y'all just write that?
Yes. Okay. So what I want to take time in our warm-up to do today is I want you guys to do the algebra part because I want you guys to see that it is all this formula, and that's the only thing you really have to know. You just got to use a little bit of logic, all right? So we're going to start off easy. You're just going to do them on your whiteboard, okay? So the first one I want you to do is I want you to rearrange this so that it is set equal to pressure. How would you rearrange it so it's just set equal to pressure? So you should have pressure equals something. So go ahead and try it on your own real quick. Okay. Sorry, I had to get my list out so I know what I want to do. All right. So you should have nRT all over V. Yes? Awesome. Okay. So once again, we're going to use that ideal gas law. Now I want you to solve for moles. How would you rearrange this so that you are solving for moles? So now we're looking for N is equal to something. And just go back to the original. Don't try and use the second one. Use this one for all of them until I change it. Okay. So what you should have is you should have PV over RT. Biggest mistake is people put RT on top, okay? So I want you to remember that when you're solving for a guy, okay, you leave that one where it is and you swing the other ones to the other side, okay? Don't try moving the end. That's usually where everybody mixes things up and then things go top, bottom where they're not supposed to go, okay? Alexis. Okay. So the next one I want you to solve for is solve for temperature. Solve for temperature. So I want T equals something. Just remember, leave the T alone, move the other ones to the other side. Okay, so hopefully this one was a little bit easier. You should have had PV over RN, or NR, whatever. Okay, are there any questions on those? Now we're going to try something else, okay? All right, so what is N talking about? What is N? N is moles, right? All right, so back in the day when we were doing our little conversions and we were trying to convert into moles, okay, we always had to end with 1 mole right here, right? What was below it? What was always below that? What? So I heard grams, but specifically which grams? Your molar mass, good, okay? So this was your molar mass every single time. So we're going to call him MW. And that just stands for molecular weight, okay? And now I'm perfectly aware yesterday we ended class talking about MW. I want you to forget all that right now. I just want you to think about algebra, okay? We're all good? So don't try and make the equation that I gave you yesterday. All right, what was always up here? What was up in this one? It was grams again, right? That was your grams of sample. So we're going to call that little m, okay? So looking at this, do you agree that that is the same thing as me saying N is equal to little m over molar mass?
Yeah.
It is, right? All you're doing is dividing. That 1 is pretty negligent, right? We don't care about it. Okay, so using that idea, I want you, I'm going to squeeze this down a little bit. Okay? What I want you to do, let me put the ideal gas law back. I want you to replace the N with what we just found, but I want you to make it pretty, meaning I don't want parentheses in it. So try to make it as easy on the eyes as possible. Okay? You can start with the parentheses, but then see how you can simplify it to make it one simple equation in the calculator. You don't have to worry about parentheses and a fraction multiplied by something. Okay? Fill it in. Let's see what you get. Okay, so I'm kind of seeing people finishing up. So is that what you got? Do you see how that is way easier on the eyes than me saying, because a lot of you guys, this is what you were doing. You were thinking like this times RT, right? Do we see how that's not so pretty on the eyes, whereas this one's just a division problem? And now if I had to rearrange this, all I know is that I can multiply the denominator out. I can do, it doesn't look so ugly, all right? But I wanted to remind you what you've learned way back in the day, that when you are multiplying by a fraction, you just shove them all together. This RT is technically over 1. So all of these guys are on top, and this is your denominator. That's the only one, okay? So I wanted you guys to know, when I show you this equation later, it's not a new equation. You guys are still using the ideal gas law, yes? Okay, all right, so next one. I want you to solve for that one. How do I set it equal to molecular weight? How can you rearrange that so it's equal to MW? Okay, did you get MRT all over PV? Yes, no, maybe so, kind of, sort of. All right, so this is what you did. Let me just show you algebraically what you did. You took this little MW, you multiplied him on both sides. You see that? So that'll get rid of him, and he's now up here. He's MW times PV. How do we get it by itself? Divide the other guys over, all right? A simple way to remember, especially when people going on to physics, so that you can just memorize this little rule, just switch them out. Oops, sorry. Switch them out. That's all you had to do, all right? Switch these two guys. Make sense? Okay, that's an easy way to do those two steps. All right, last one, I promise. You guys ready? Oh, no, we have 2 more, sorry. All right. Aren't you excited? Okay. Let me actually rewrite this just a little bit prettier. All right, so this is what we were left with, right? Okay. What did I just circle? I heard M over V, yeah. So what is M? Mass. What is V? What equals mass divided by volume? Mass over volume. Density, exactly, all right? So density is a D. Replace it. Put the D in there. Where is it going to go? What is it going to look like now? Substitute the D in for the M over V. Rewrite it. So in other words, if that's really hard for you to see, this is what you're doing, right? We have RT up here and P's over here. How can you switch out the M over V with a D? Where does it go, top or bottom? Okay, all good? All right, so this is what I left you guys with yesterday, I believe, where it was meow is dirt over pee, and the way to remember it is cats put dirt over their pee after they go to the bathroom, right? All right, so, but once again, have we changed, or is this still the ideal gas law? Still the ideal gas law. All right, one more. This will be your last one, because you guys are going to have to use it today. I want you to now rearrange it to solve for density. All right, so like I was saying, leave density where it is. Get rid of the p first. What do we do with the p? Multiply both sides by p, right? Okay, so now we got rid of that. We now have p times mw is equal to dRt. What do we do? Divide it over. And that's what you're left with. So you're going to be using this equation at one point in your life today. But once again, okay, it's still ideal gas law, okay? And it's you kind of building this ability to substitute things in and rearrange it, all right? You got to have that skill. And especially, like I said, especially my people going to physics. That's your entire year right there, okay? If you can master this skill, you're going to be awesome, okay? So, hopefully I kind of helped you out with how to remember how to do things like that. Okay, I know it's been a while for some of y'all. So, so just remember that you know how to do this, all right? And it's all coming from ideal gas law. We got that? Sweet. Okay, so what we're going to do next is just a quick review over what we covered yesterday, all right? Which we had the same variables, right? Nothing changed there. We noticed that with R, you had 3 different types. Who do we look at? Pressure. We look at pressure, exactly. All right, so make sure you are paying attention to your pressure units. And then what else was important about volume? What did it have to be in? Liters. Good, all right. And so when we go to solve it, you figure out that, oh, it's fact. What's the missing number? Okay, you look straight at your units for pressure, and you figure out your R, all the other guys, and then you just plug in. I would rearrange your ideal gas law first, okay? All right, cool. So you guys are going to do this page today, and those are the answers for you to check yourself, okay? Do you guys have this page yet? If I didn't hand it to you, then you don't have it. Okay, I have it for you. All right. So if you're at home watching, go ahead and pause the video and take a look at the questions with the answers, and you answer it on your own piece of paper. Okay. So a lot of this part is going to be straight from the end of your guys' warm-up today, all right? So yesterday we finished class by writing down that molecular weight, or molar mass, is equal to dirt over P. Where's the T? There you go. Okay? And so all that we're going to do is we're just going to kind of show what we did in our warm-ups. We're going to do it really quick, though. Okay? So we're not going to sit there and derive all of them, because you guys have now seen that that's where it's coming from. Okay? So just a reminder that N is equal to moles, right? So we know that we can rearrange our ideal gas laws. That's awesome. Sorry, my iPad fell. That's awkward. All right, there you go. So PV equals nRT. So we can rearrange this to be PV over RT, right? But today we also found that it can be what? How do we make that conversion? Hint is you have all these variables right here. What did we say? When you did your railroad tracks, who did you divide by? Molar mass. All right, sounds great. Okay, good. So it was your mass divided by your molar mass, right? Okay, so that's what we kind of concluded today. So moles are a character, and we can now substitute the mole with a mass of a sample. So hopefully you're starting to see where stoichiometry is going to start playing a role next week, okay? So mass of a sample, and we're going to put a little W next to that guy. This is your molar mass, okay? All right, so big idea from the warm-up was that we can substitute that little mass over molar mass for N. And once we did that, we now had the ability to rearrange it, and then we could get density, and we could get all those other versions, okay? But this is kind of where it's going to go, okay? Don't feel like we need to say much more about that, all right? So let's go ahead and take a look at the problem right here. So the problem says that at 28 degrees Celsius and 0.974 atm, 1 liter of gas is a mass of blah, blah, blah. So what's the molar mass? So it's asking for MW, right? Okay? And I taught you guys to memorize, if you want, the meow is equal to dirt over P. Okay? But we know that they're not giving us density. Instead, what did they give us? They gave us a mass and a volume. Exactly. So we know that we can replace that density with that. So we're going to just rewrite it real quick. We're going to say mass RT all over PV. Okay? And that's going to be what you guys are actually plugging in for. And it's what you guys did on your lab. All right? Okay, so let's just make sure everything else is good. I'm going to leave things where they are. This temperature, what are we going to have to do to it? Add 273, so make it Kelvin, so that's 301. Okay. Our pressure is good, but what else? What other information does that pressure tell me? R. Which R are we going to be using for that? Good, 0.0821. Okay. Huh? Oh, you're sorry. All right, so we got our R value from our pressure, and now we just straight plug in, okay? So we're going to say molecular weight is going to be the mass of 5.16. This is where parentheses are going to be really important if you're trying to plug them all in. 0.0821, sorry for my handwriting, times 301 for temperature. And I'm going to close my parentheses in my calculator. Push divide, open a new set of parentheses. I'm going to put my pressure, 0.974 times my volume of 1 liter, which I guess you don't really have to do that one, right? So go ahead and plug that in. Once you have an answer, go ahead and shout it out so that we can check it. And we don't have to do these notes because we have kind of covered that in the warm-up. So once you've got it, shout it out, and we'll second it. But you do want to practice plugging these in. What are you guys getting? Good. 130.9. I agree. Okay, what are the units for molar mass? Careful with this. Moles is involved, but it's grams over moles. Good. There you go. And that's your answer. Okay. Now this little lower part, all that they're saying, they just want to remind you what we talked about earlier, which is that density is mass over volume. Okay. And that leads us to that last problem. We're going to use this as a warm-up next week, by the way. This one, so don't cross that part out. We're going to use that as a warm-up. We're going to use that logic where opposite sides of the equal sign versus same side, okay? So number 5 sets us up for what is the density, right? And that was that last equation that I made you guys write in your warm-up, right? So we can always rearrange dirt over P to solve for density. Multiply P out, divide the RT over, and you are just plugging in that, okay? The rest of it is pretty straightforward. Also be aware, molar mass is usually not given to you. They want you to solve for it. Right here it's telling you that you have ammonia. If I look up ammonia on my periodic table, I know that 1N is about 14 plus 3 hydrogens. So we got about 17. Okay? And then you would just use that, plug it in, and you would get your answer. Do you guys have any questions? Okay.